Hello, I'm Spandan Naskar. I'm a PhD scholar in the Department of Hydrology, and this is my work, Fate of Organoarsenic Compounds in the Presence of Iron Minerals and Soils in the Groundwater Matrix. Now, arsenic or arsenic poisoning in the groundwater is a global environmental calamity affecting millions of people per annum, causing hyperpigmentation, and in several cases, cancer as well. There are a lot of studies exist on the inorganic arsenic, fate and transport, but very few exist on the organoarsenic contaminants. Now, these are the major objectives of this study, which are sorption of roxazone and p-arsenalic acid with naturally occurring iron minerals, fate of roxazone and p-arsenalic acid with common clay minerals, and lastly, sorption of roxazone and p-arsenalic acid with different types of soil. Now, moving on to the methodology, we prepared three major types of iron minerals, which are magnetite, hematite, and magnemite through wet chemical precipitation method in the laboratory. And we collected three types of major agricultural soil, which are red soil, black soil, and alluvial soil. Along with kaolinite, bentonite, we perform batch experiments. And these are the ACM images of the synthesized iron minerals, and these are the results. As we can clearly see that magnetite has higher sorption, followed by hematite and magnemite, in case of roxazone and p-arsenalic acid. In case of soil, red alluvial soil has higher sorption, followed by these two are equal, red soil and black soil. Similar observations can be seen in case of p-arsenic acid in the soil as well. So, to the conclusion, roxazone and p-arsenic acid had negligible interaction with the clay minerals. Roxazone had higher sorption in all minerals and soils in comparison to PA minerals. In sorption percentage, in decreasing order are magnetite, magnemite, and hematite. And in case of soil, alluvial soil showed the highest sorption, followed by red soil and black soil. And alluvial soil has higher TOC, and it showed the higher sorption both in case of PA and ROX. So lastly, we can say that the very low sorption of roxazone and PA in the most iron minerals and agricultural soil reflect their poor retention capacity, indicating a potential risk of groundwater contamination. Thank you.